This is exercise 2 of topic metals. Mention the question in which you have doubts, so I'll discuss that question. Question 2, part C. Yeah. Question 2. C. The graph shows the malleability of iron changes as a percentage of the carbon. Changes. So you can see as we increase the percentage of the carbon, it becomes less malleable. Less malleable means that the layers cannot slide over each other. And reason why the layers cannot slide over each other, because the size of the carbon atom is different from the size of the iron. So just explanation of the graph, they do not ask for reason. The question is describe how the malleability of iron changes as a percentage of the carbon change. So as you can read from this graph, increasing the percentage of the carbon reduces the malleability. So if we increase percentage of carbon, it will reduce the malleability. Then in the next question, they ask iron obtained from a blast furnace contain a high levels of carbon. Explain how amount of carbon in the iron can be decreased. So how we can decrease? Basically, it's a molten iron we use. It's the method from iron to steel. We below the oxygen because the oxygen react with carbon and it will form carbon dioxide. So blow the oxygen or add oxygen and react with carbon to form carbon dioxide. So react with add oxygen, which react with carbon to form carbon dioxide and reduces the percentage. Then the next question is question 4a. In this question, aluminium is very important. Aluminium is extracted from its ore bauxite by electrolysis. Bauxite is an impure aluminium oxide. Describe how aluminium oxide is extracted from bauxite. Include an ionic half equation. So you can mention the whole process, the complete process, but the distribution of the marks. So first what we do, like example, we add sodium hydroxide. Iron hydroxide will be insoluble, aluminum hydroxide or sodium aluminate will be dissolved, then filter, then add cryolite. You can mention those points as well. The marks are not included in the marks, but you can mention those points because in this question, it's not specified that, because they mention here how aluminum is extracted from bauxite. So starting with the bauxite, you can mention the whole process. Then 7C1. Describe the bonding in iron, include a diagram. Bonding in iron, because iron is a metal. So the structure of the metal has a lattice of a positive ion, regular arrangement of the positive ion, and delocalize electrons. So even if they ask describe a bonding in magnesium, aluminium, lead, any metal is there. So all of these metals, what they have a lattice of a positive ion and the free electrons, which are held together by strong electrostatic force. So positive ions in a sea of electron held together by strong electrostatic force. That's known as strong electrostatic force between positive ion or cations and electrodes. Then use your diagram in C1. Explain why iron is malleable. So why the metals are malleable? Because the layers, they have a layer structure and these layers can slide over each other without breaking. So due to the sliding of the layers can slide over each other without breaking. That's why metals are malleable. If there was like an alloy means mixture of the metal, so it contained different size atoms which increase the friction between the surfaces, between the layers. So layers cannot slide over each other due to the presence of impurity. It reduces the malleability. That's why pure metals are more malleable as compared to the alloys. Then iron containing a small amount of carbon known as steel. Why steel is less malleable than iron? So that's the same reason that the particles have different size, so the layers cannot slide over each other. That's why the malleability changes. Any other question related to this? Exercise, exercise 2 of metals. Any other question or doubt? Any other doubt in this? So otherwise I'll move on. Okay, so